Okay, I'm going to argue this next question is a little bit silly even to suggest. However, it is given as a math problem that we're supposed to solve, so I guess I'll have to work it. But I don't think a water taxi going around in the shape of a parabola that I have to worry about it hitting the path that a water skier is going, and it's in a straight path, so that's like a line. So the first equation is the parabola, and that's just given. So we know that the 0.5 x minus 14 squared, if you wanted to think about that, you could say that's 14 units to the right, and then it opens at about half the rate. So if it's a little bit slower, that means it's going to be a little wider parabola. Now, the other thing, though, is we have to figure out, well, what's the line that the points 6, 4, because I want to just put this in the two equations in Desmos and look at it like we've been doing the other problems. Or if you had a graphing calculator, you could use that as well. So if I have these 2 points, what's the equation of that line? Y equals mx plus b sort of thing. The water skier is just going in a straight line. I don't think it says that exactly, but it says it starts at a point and ends at a point. We have to assume it's doing the same thing. So let's say this is my y, and I'm up at 4. So if you think about it, you're up at 4. And then I go to this y, which is down at 4. So I'm kind of thinking of my rise over run here. So I went down 8, did I not? So from here to here. And then if I'm talking about my run, my x, if this is at 6 and it went to 8, that's to the right too. So I'm at 6 and I go to 8. So this one moved down 8 and this one went right 2 to go from 6 to 8. So my slope here is a -4. I kind of just do this visualizing factor all the time when I do slope. 4 to -4 on a vertical would be down 8. And 6 over to 8, you have to do them in the same direction here. This is a big thing. Notice I put the arrows here to remind myself. So 6 to 8 would be a +2. -8 divided by 2 is a -4. So, I have a line that's moving in a downward direction. It'd be kind of steep, actually. But then how do I find my y-intercept to go with that, to put it in the Desmos here in a minute? So do you remember y equals mx plus b? I'm going to just put this -4 in for that m. I'll use the 6, 4 up here. The 6 is my x, correct? And the y is the 4. So I'm going to put the 4 for this y. My m, my slope was -4, times the x that I'm using for this 4 was the 6 plus b. So I get a -24 here. Move that to the other side by adding it. 24 added onto that would be a 28 for my y-intercept, so my b. So if I have a b of 28, I've got this m here, my slope was -4. That gives me the equation here to be y equals m, -4x plus b, the 28. So I'm going to put that equation and this equation in. And it says, write a system of equations. There's my systems of equations to model the problem. But then it says, could they intersect? And then that's where I'm going to jump back over to Desmos and let Desmos do all of the work for me so I can just type it in and let it figure out if it's correct. So again, I got to have these two equations, the 0.5 times the quantity x minus 14 squared, and that's what the y equals, and the other one y equals the linear -4x plus 28. And so let me get it so you guys can see what I'm doing in Desmos here. All right, hopefully you're seeing Desmos now. And my two equations again, the 0.5 x minus 14 quantities, whoops, that's not a quantity, shift 6 first, then squared. And my linear one here was -4x plus 28. So if I saw that right, I think the graphs were way up here somewhere. I could also use my roller on top of the mouse to see. And it definitely looks like our skier and the water taxi are safe. It doesn't look like anybody's going to run into each other when you look at those graphs of those two problems. So the original question again back there, the original question here asked, is it possible that the water skiers could collide with the taxi? And I would say, unless I made a mistake. It sure does not look like that would be the case.